All right, so now please get to this link. I posted in the everyone's. Again, I always forget. You don't have to do it now. We will give you some time at the end of this session, but they can definitely spend time at home to practice that and go through the code because there are a lot of things going on there. I pasted there into the everyone's channel. Please have a look. And thanks a lot for the TAs. Great work. They're super busy with answering the questions. Beautiful. So now I go to this one, which actually has the ML pipeline MNest. Again, please, when you go home, read the first part. There's some explanation about what's going on there and what is happening as my, what I'm actually explaining here. So the first part of, yes, please. Oh, yeah. So again, you can run it locally, or you can, again, load it to your notebooks.azure.com. Yeah. But what we want to do is that we want to build construct a pipeline from our development environment to see how it works, and then we will automate that hopefully in the next 20 minutes. So I'm going to go very quickly on this. So the first part are completely the same as the previous one. Is not really different. The first important part is the data dependencies. So when you go back to this diagram that shows you what's going on within this pipeline, the data dependency within the first step and the second step is the data should be landed into that default storage, and then we want to execute it, right? So with data dependency, you can basically define and formalize the sequence of the action. This is one way to basically provide the sequences. In order to define it, first, I again, similar to the previous notebook, I get the default storage as data store. If you remember, the data store name was named workspace blob store. Within this default, again, I will be getting the access or the object which points out to that default data store, which is again the blob storage. I create two compute nodes, one a GPU node and the other one is a CPU node. Again, all of them have one single node because it's already created. It doesn't spend time to get it again. So I can list it here, see that two of them are available. So now what I want to do, I want to be able to actually access this data store through the pipeline. In order to do that, I create an object called data pipeline data. And within pipeline data, I can introduce a data store. Again, the data store can be default, or I can create a new data store. Also, I can define and point it to a data set. That can also be a data set. So these two are possible. So I create this pipeline data from the default storage account that I have already created there. And now I want to construct the steps. So again, going back to the definition, each step is an atomic part independent from each other, which does one job. Going back to this explanation, this part requires a CPU node, nothing complicated. And also, I don't want to get any complicated Docker be deployed because it's a very basic Python script. I need a pure and base CPU image Docker. So in order to define what I explained here, I can basically provide a configuration, run configuration. So I can let it know that I want an environment which requires the default CPU image. That's actually a string, which is pointing to a particular image name. I want these two packages to be installed as a conda requirement. And that's it. I want to be Docker enabled, deploy this image into the node, and that's it. So I provide this run configuration to when I want to create this step. So again, going back to the steps, the first step is a pure Python script. Let me show you what does that Python script do. It's super, again, simple. So I mentioned that my source directory, which contains all of the files, all of the Python file which is required for this particular step, is inside this directory. I go inside, so there are like 2 files, which both of them will be pushed to the remote compute target whenever I submit it. So what it does, the first step, it basically gets the file from that shared environment, because I already downloaded that. So it's like a couple of functions. First, it defines, it gets the arguments. This is basically the only argument I'm passing to this, and that is the output data extract. Again, I want to download the file. I want to save it somewhere. I want to save it in the output folder, right? This is the output data set that I want to store it. I'm getting this, I'm passing the argument to this, and then basically within this function I'm defining some of the arguments I'm getting. This is the main function. The next step is basically to download all of these files. So what it does, it downloads them into this folder, which is called raw. It creates a raw folder under the default storage account. So in the default storage, there was a MNIST folder, if you remember. It creates a raw files under that. It downloads everything there. And then once everything is downloaded, it runs the second function, which does a normalization. So it loads it from the raw folder, normalizes it. It basically keeps them into, oh, you forgot to tell me, zoom in. It keeps it into, no problem. Yeah, so it basically keeps it into these NumPy data frames. The return of this function is basically to return the NumPys, which is normalized. And then what it does, it saves it into the output extract. Again, the output extract is the parameter which I'm passing to this Python file. So what it does, it basically creates a raw folder, copies it there, and then once it is downloaded, it is loaded under there, it processes it, saves it under basically the process folder. Now, my training job can basically pick up the NumPy binaries from that process and then start my training here. So, yeah, so by Python script step, I define this. I provide the run configuration, what Docker I want to use. I want to define like target compute to be the CPU, and that's it.
What's causing the trigger?
Nothing. Nothing is done actually. This is a lazy evaluation.
Oh.
Yeah. Oh yeah. So the question is that when I run it, does anything get triggered, right? Yeah. So when I add the step, there's a conceptualized step is created within the object of extract data step. It keeps a step. Later on, I want to orchestrate all of these steps and construct basically the full pipeline. So now, basically, I run this, and the step gets created. The next step, if you remember again, that's a TensorFlow job. Going to the code is under training folder. It's train.py. What it does, it basically first loads the data. First of all, it gets the arguments that I'm passing to it, like the input data location, batch size, and everything, similar to the previous example. Then the data load gets called. In the data load, what it does, it basically accesses that input data, which I'm passing through the arguments here. Input data is an argument I'm passing. Do you remember again, there was a process folder I'm passing to this train.py. And then what it does, it basically loads the data into these NumPy objects. Then it calls a train, and the train is exactly similar to what we did on locally on the previous example. It goes through all of the epochs that I provide. I think it was 20 epochs, and the batch size I think it was 50, and basically runs the whole thing, logs everything that happens during the process under the run of that step, and then finally saves everything under its local output folder. Again, similar, nothing is different from the previous example that I executed. The only thing which is different, I'm adding a properties, which I'm adding a release ID and type train. What properties can help me to do, it can help me to fetch and query my runs based on a particular value. So I can say, give me all of the runs which are related to run release ID 1. And you can think of release ID, again, as a hack, like as my process of doing things, is to basically group a set of runs on a particular version number, for instance. If like a version 1, I want to release ID 1, version 2, release ID 2. And all of the runs I submit will get release ID 0, 1, 2, 3. We can bundle them logically together. So now, again, I submitted this training job, the run will get a release ID, and it keeps the model. The way I express it using the similarly TensorFlow class, like the previous example. But this step needs to be, instead of the previous step, which was a Python script, because I use actually a TensorFlow object, which you could Dockerize, like abstraction for the Dockers. I use the estimator step, where I actually provide this estimator, which I defined here, the location, all of the parameters that I need to pass to this, and basically like this, I define the second step. So the training step keeps everything related to the second step. This step can be a hyperdrive, like a hyperparameter tuning, like it can be so many parameters, and also the target compute can be a large cluster to train all of the permutations for the hyperparameter, but keep it simple this time. And now we go to the second step. Going to this one, the second step was what? Getting the last run, checking whether this last run had a better model or not. We want to evaluate the model and register the new model. So going to this, I'm actually constructing the last step, which is the model evaluation, passing all of these parameters, and what it does, just quickly, inside the register model, what it does, it basically gets all of the runs, gets the last run, and checks whether the final accuracy, this is the new model accuracy, and this is assumes that this is the production, gets also the one before this, and compares the accuracy metric. Like I get actually, do you remember there was a final accuracy metric I was collecting the previous jobs, right? So it fetches the previous model in production and the latest model and checks whether the final accuracy matches or not. Very simple test. And then if it is successful, what it does, it basically registers the model under this name and the same release ID that I provided. Like all of them are related to version 1, for instance. That's it. And again, it's like a Python script. There is nothing related to like anything complicated. It doesn't require any GPU or anything. So I just keep it simple. And something about here is that I basically, by providing the data dependencies, yep. Based on the data dependencies, I can provide the next step and the last step, right? So like here, I said the output, there is a function here in the first step is called output. So I say output is the MNIST data store. Like this is the dependency as the output. And here in the next step, I say the input is the processed means data store. It means that the output needs to be connected to this input. I'm basically defining some sort of data dependency as the sequence. But because the last one doesn't have anything data, right? Doesn't need to get anything from the data and nothing, I have to explicitly mention that run it after the training step, right? Otherwise, it will run simultaneously with the other steps. So once it is executed, in the final thing that I need to do, I basically have to provide all of the steps based on the way that in a list, and then create a pipeline object. And then I need to submit the pipeline under any experiment that I want. If you remember in the taxonomy, the pipelines and the experiment were different. In the execution time, I need to say that which experiment this pipeline should be executed under. The reason is that I want to keep the run logs, right? and I want to specify which which experiment object needs to keep all of these runs. So when I run this, it basically, what it does, it will construct this and then creates a logical pipeline in the Azure ML and then orchestrates the job that I wanted to execute. So again, this is a little bit more fancier, but again, there are three simple steps, nothing really crazy, and this get executed there. Yes, please.
Why you use the estimator step as opposed to TensorFlow class?
Okay, so in order to submit the steps, so TensorFlow is just an estimator, right? But in order to construct step, I need to create the step objects. And because I want to submit a TensorFlow estimator as one of the steps, I need to define estimator step rather than Python script step. And then the rest of the story. Yes, please.
Is there a way to visualize the pipeline?
So because many of that was cache and the Dockers are deployed, so I get it. So every step is an independent run for itself, right? So if I click on it, so I can basically see that that's the training step of the pipeline, and its run configuration is different from the data extraction and the data validation, right? And now the validation is done. So now if I go to the models, I can basically see the model which is provided there. And if this model is basically saved here or not. So yeah, this is the one, right? Yeah. All right, so once the pipeline is built, I can treat it like any run object, and every step are as child run, basically in that way. But it is still not published, so I don't have an endpoint to that. I need to call the publish function of the pipeline run, and then I'm able basically to see it within the pipeline step here. So if I go to the pipeline, the old UI, or the endpoints, which is a different name in the new UI, I will be able to actually see, and also need to go to the pipeline endpoint. You will be able actually to see the pipelines. This is the one that I just created, is the pipeline which is just published there. And I can basically run it if I want, or basically do whatever I want, right? So that pipeline is a piece of steps constructed together, provided through an endpoint. So now, after I publish this, basically, I can see this. This is the URL to that endpoint. So I can access to that endpoint and then run it, trigger it. Or there's a concept called parameters for the pipelines. I didn't use it, which you can parameterize the pipeline, change everything within the code and pass it to the pipeline to get your custom values. And finally, I will be able to basically trigger it using any post request. So there, I get basically, I want to construct a post request, and I basically want to submit the post request to this endpoint and execute the pipeline again if it wants. So, but that's the tricky part because it requires the authentication. It requires this to be authenticated. In order to construct this post request, I have to provide the authentication information within the object of the post request object. I have to encapsulate it there. One of the values is the header, which keeps the authentication code here, which I generate. The reason I'm getting this without any, simply because I already logged in before. So if it was not already logged in, it will ask me to log in. And that's actually the interactive way of getting the authentication code. The next step, I wanted to show you how you can basically do it automatically through a machine without any interactive authentication required. but I think we don't have time. We have only 10 minutes. So we will do it in the first part of the next session to how basically integrate this pipeline into your CI/CD pipeline. Yeah, but before I finish, there are a couple of things here that is interesting to know, that basically every time you can get this pipeline and publish it, you can schedule it, like you can say, run it every Wednesday at this particular time of the day, or you can even say that if this new data hits this location within Azure Data Storage, again, hit this pipeline. We assume that the new data hits in, so just run it after the data is hit. There are multiple ways to trigger that. And of course, one way is through the post request to trigger that pipeline. So of course, you can build a very sophisticated ML job. That was the very simple one to just show you how to build a simple one. And for your capstone project, this became a little bit more complicated. Not too complicated, but a little bit more complicated. Yeah. Awesome. Any question? You have 10 minutes. I think it went better than last time. Last time I managed to go through 50%. Yeah, this please.
I have a difficult time seeing how to do this in AWS actually. Cause these pipeline objects are pretty convenient. Like they're really nice little APIs.
Is it they're built really for the ML jobs?
Yeah.
100% agree with you. So the thing you can reproduce it is basically probably use Kubeflow. Kubeflow is open source way of constructing ML pipelines. But that's super Docker heavy, so you need to be very good with Dockers. Yeah, which I think you are, so you should be good. Yes, please. Yeah.
Do you have any experience with Kubeflow, or are we gonna be talking about Kubeflow at all?
Unfortunately, we don't really have. I was hoping to provide some content on the Kubeflow, like how this is related to that one, but we don't really have. You see that is really limited time to provide anything on Kubeflow. But the general concept is that basically you can construct the same logical pipeline and deploy it in Kubernetes cluster. So you can run it on anything which runs Docker, in particular Kubernetes. But it is constrained within Kubernetes, so if you want to use anything outside of Kubernetes, you're not able to do that, which makes it limited somehow. And it overuses Dockers. So here, you didn't need to do anything about Dockers. It was very abstracted, but again, in Kubeflow, you have to do a lot of management for the Dockers. It really makes your life really complicated.
Yeah. Besides the official Kubeflow docs, do you have any resources that you would recommend for installing Kubeflow and stuff like that?
Yeah. Again, all of the open documents is over provided, and I think it's good to study if you want to deploy it in a cloud. Good to study that those documents are provided by those cloud providers. Like AWS has its own document for Kubeflow. Azure has its own document for how to deploy Kubeflow, and also similarly on GCP. That's easier way to get to that end state faster. Yes, please.
Say except TensorFlow, what's supported is PyTorch and Keras.
Yeah. So these estimators, from train.dnn, you can basically import PyTorch or Chainer or scikit-learn. MXNet, I think is supported. Yeah, but if it is not, you can basically install MXNet as a custom package, right?
Is Keras supported too?
Keras on top of TensorFlow, yes, support.
Oh.
Yeah, MXNet, yeah. Microsoft does
What's
support.
The Microsoft one?
So it was CNTK, but got yeah, I cannot really say anything here, but it's not really very active, but now is joint forces with Facebook with PyTorch and Chainer. Yeah, we do work on that. There's something called Onyx Runtime, which I'm hopefully can touch it, which is an interesting basically result of working with Facebook and Amazon, which is an open neural net framework basically. Yeah. Which is a good thing, works very well with PyTorch also, yeah. Boosts the performance significantly too. Yes, please.
Do we need to close any of the resources that you opened up?
Very good. I forgot to forget. So this, if you go to the last part of it, I forgot to do it, just make sure you just name it, compute, target.delete. These are the only part that's going to be expensive. The rest are cheap. So compute CPU dot delete. Make sure you do this, otherwise you will burn your credit. And also, go to your portal. When you go to the home page, you can search for your subscription. I share it quickly. And then like the free trial is what I'm using for this workshop. And here you will see the cost. So you will see that how much it is burnt and how much is left while it's loading. Yeah, but make sure you delete all of those. The most expensive parts are only the compute parts. Make sure you delete those. Yes, please.
Are you going to post that command? The complete target CPU.delete?
This one? Yeah, just compute name and .delete function. I will push this again to the repository that you get the latest updates. Yeah. Also, you can go to the portal and go to the compute and just hit delete. So in the compute, if you go to the new UI, you have to go to the training clusters, and then you will hit this one and then hit delete. Make sure you do this because otherwise it will be charged. Any other question?
Oh, is it just enough to delete it on like the ml.azure.com?
Yeah, both of them does the same thing, yeah. And as soon as you submit delete, you will be stopped paid. So if it takes like 2 hours to get these deallocated, it's not your problem anymore. Anytime.